So yesterday we started reviewing Chapter 2, which is Fme Server and Data Management, and we had a look at a couple of the different ways that we can start publishing source datasets to be used with our workspaces on Fme Server. So firstly, we reviewed database and web connections, and then we looked at publishing files up with the workspace at runtime, and we also looked at temporary upload in the Fme Server interface when we choose to run a workspace as an author. So the final method for uploading data is a more permanent solution, and that's uploading data to the Fme Server resources system. So we looked at using the Fme Server web interface rather than specifying the source data to be uploaded at runtime. We can put this in a more permanent location on our Fme Server system, which can then be referenced when running any workspace that's on the Fme Server. So, as well as user parameters, we also have a number of Fme parameters on Fme Desktop that have been designed specifically for use with Fme Server. So you'll be able to view these in the Fme Desktop window under the Navigator, under the Fme Server parameters. And when you view these in Desktop, you'll see that none of the values for these parameters have currently been set. However, if you were to use these once published up to Fme Server will recognize these shortcuts, and it will go and populate the values. So for example, with the Fme security user, if you were to use this in a workspace, once run on Fme Server, this value would be populated with the user that is currently running that workspace. However, this means that if you were to use these parameters when running the workspace in Fme Desktop, it wouldn't be able to recognize where these values should be coming from, and therefore it won't populate these values. So in order to use these parameters and test your workspaces on the desktop interface, you can go ahead and populate these values with temporary ones in local places on your desktop. And then once the workspace has been published up to Fme Server, these will be overwritten with the values from the Fme Server interface. So the one of these Fme Server parameters that we are particularly interested in for data management is the Fme Shared Resource Data variable. This parameter returns the path to the data folder in the resources in Fme Server. And this means that when we're specifying either a source or a destination dataset, we can use this variable in the parameter, and then once published to Fme Server, it would look directly into this data folder in resources. So as I mentioned, this parameter in desktop, if you were to specify this, would be the cogwheel would be red, and that's because Fme Desktop doesn't recognize where this value is on Fme Server. So if we wanted to run this on desktop, we could then go and populate the Fme Shared Resource Data parameter value with a local destination on desktop. So for example, the Fme Data 2019 folder that we've been using during the exercises so far. And that would mean that the workspace was able to run on desktop, and then once published to server, it would look in the resources folder. So under the Fme Server parameters listed in Fme Desktop, you'll see the Fme Shared Resource Data, and you'll also see the Fme Shared Resource Temp parameters. However, there is actually a shortcut to all of the resources in Fme Server. So these are all available under the file properties in Fme Server. So you would be able to do this with any resources on the Fme Server interface, including any resource connections you may create yourself as well. So that's just a short recap of what we covered at the end of yesterday. We did get started on this exercise. However, we cut it short halfway through just so that we didn't run over time. So we're going to start from the beginning of this exercise just to make sure that everybody's caught up. So the first thing that we want to do is open the Fme Server web interface. And in this exercise today, we're going to take the workspace that we created yesterday using the voting places and neighborhoods. And yesterday we were looking at temporary uploading data to run this workspace. However, today what we want to look at is we want to reference these data source data sets and also the destination in the Fme Server resources folder. And this means that we want to take the publish parameters away so that the end user doesn't have the option to manipulate what source data is being run. Instead, it will always be run from what we've specified in this workspace that we've uploaded to resources. So the first thing to do is open up Fme Server. So if you haven't already done that today, then you can open a new web browser and you'll be faced with the Fme Server login page. And at this point, we want to be logging in with the admin username and password so that we are logging into Fme Server as an administrator user. By logging in as an administrator, this means that we have access to the Fme Server in its entirety, which can ensure that we can set up these resources so that they are accessible to all of these workspaces. So the next step in this exercise is that we want to create a series of folders under the resources data folder so that we can upload the source data sets, and we can also specify an output folder for the destination dataset to be written into. So the first thing that we want to do is select resources on the menu on the left-hand side. And then generally we recommend using the data folder for all of your source and output data. So we'll enter the data folder under resources. And if you were able to do this step yesterday, then you would already see there is an election folder in this resources data location. If you weren't able to complete this step yesterday, then all we did here was we selected this create folder button to create a new folder under resources data, and you can simply call that folder election. Okay, so once we've done that, within the election folder, we want to create two additional subfolders. We want to create an input folder where we're going to upload the elections voting and the Vancouver neighborhoods input data. And then we want to create an output folder that we are going to set the destination dataset to write to. So again, in order to do that, we can repeat the process that we did for creating the election folder, and we can select the Create Folder button and repeat this process for both the input and the output folder. The next step that we want to take is we want to upload the source data into this input folder so that when we go and modify the workspace, we can refer to this input folder location and we can ensure that we are referring to files that actually exist, so this workspace will run correctly. So to do this, we can select Upload. We're uploading files. And then we'll enter Fme Data 2019 folder, which you should be able to see under the Quick Access bar. And then we'll have a look in Data. And we need to update from 2 separate folders here. So firstly, we can upload the elections voting, which is in the elections folder. So for this one, you will need to upload the schema file, the electionsvoting.xsd, and we also need to upload the GML file. You may notice that this file is actually called New Election Voting if you followed the exercise 2.1 with me yesterday. So that's fine. You can simply select election voting and the GML file as well. And then you can open those and you should see that they are uploaded into the input folder. And once you've done that, we can then upload the Vancouver neighborhoods file. So we can repeat the process by selecting Upload, Files, and this time we'll go back into the Fme Data 2019 folder, available under the Quick Access menu. And then we'll select Data. And the Vancouver Neighborhoods KML file is in Boundaries. So we can then go into the Boundaries folder and be sure to select that Vancouver Neighborhoods KML file. I'll just give everyone a moment to reach that step. So in your input, you should have 3 separate files, 2 election voting files, and then lastly, a Vancouver neighborhoods file. So at this point, we now have all of the source datasets available on our Fme server to run our workspace. So this means that when we run our workspace going forward, we'll no longer need to perform any temporary upload or publishing with that one individual workspace. And these files are now available to run on multiple different Fme workspaces, not just the one we are currently working with. Now, the second folder that we created on Fme server was the election output folder. However, you might recall that our workspace is currently writing to a null writer. And that's essentially just a placeholder, and it means that currently there's actually no data being written out anywhere. So in order to see a file written to the output folder, we need to go back into Fme Workbench and update that writer. So in order to do this, you can open up Fme Workbench and you can open the workbench that we created in exercise 2.1, or alternatively, you can open the Start Workspace specified in this exercise 2.2 heading here. So I'll work through opening that one with you. So when we open Fme Workbench, let me just close this so I can show you the whole process. So if you saved your workspace, you should see it listed under recent workspaces. So you can either open that exercise that we created yesterday, or you can select this yellow folder open icon, and we can navigate to the workspace in this location. So we can select Fme Data 2019, and this time we'll go into the Workspaces folder. And then we'll look under the server authoring course. And this time we're looking at data handling exercise 2 begin. So I'll just give everyone a moment to upload that workspace, and then we'll start on step 4 for editing this workspace. So now that we've made a decision about where we want to write our data out to, we can add a writer, and this time we're going to be adding a Geodatabase Writer so that we can add both these point and area layer into a single data set. So in order to do that, we're going to add a writer by selecting Writers in the top of the menu and then selecting the Add Writer button. For the writer format, you can select Esri Geodatabase and make sure that this is the File Geodatabase Open API. There'll be a number of options there for you when you start typing Esri Geodatabase, so just make sure it's the Open API writer format. And then for the writer dataset here, we can simply copy this location across. Our destination dataset doesn't exist yet, so this is a new folder that we're going to be creating in this location. So for now, we're simply specifying a location in our local Fme Data 2019 repository so that we can make sure that the workspace is running correctly before we update it to the Fme Server location. And lastly, in this writer window, we want to change the feature class definition from copy from reader to none. And this is because we already have existing feature types from the null writer, so we don't want to duplicate these feature types. We're simply going to make a transition from the null writer over to the Esri Geodatabase Writer, so we can leave the feature class set to none for now. However, once you click OK, even though you don't see a change in the canvas, you should see under the navigator there is now a department data writer listed under here as well. So at the moment, our workspace is still writing these datasets out to the null writer. So in order to make this transition over to the Geodatabase Writer, we can simply select the cogwheel for each of the writers, and we can make a change to the writer parameter from null to department data. So firstly, you can open the voting places using the cogwheel, and then under the parameters general, select the drop-down list for the writer, and you should now be able to see department data file GDB. And then you'll need to specify the geometry. You'll notice that this is an additional parameter that's come up specifically for this writer. And for the voting places, we can specify points. So I've just seen that somebody wasn't able to find the department data.gdb. Since this is a folder that doesn't exist yet, when you were adding that writer, you just simply needed to type in department data.gdb following this file path here. And that will create the output folder for you when we write this dataset out. So once we've changed the voting places, we can then repeat the process with the neighborhoods folder. So we can go into neighborhoods, and then we'll repeat the process. So under general, under the writer, we'll change this to department data. And this will also expose some additional parameters. And this time we want to specify the geometry to GeoDB polygon. Since this is polygon rather than point data, this will ensure that it gets written out. And then we select OK. So I just want to make sure everybody's reached that point. So if you could raise your hand once you've completed this workspace. And if you're having any problems, if you just write a question into the chat, and I can go through any of the processes that we've missed for this. And if you've completed it, then you can just raise your hand so I know that we're ready to move on. Yeah, so it looks like if you weren't able to follow the workspace through at this point, then there will be an end workspace for this exercise in the same location. There's still a few changes that we will be making though. So if you'd like to follow on, I'd be happy to repeat the steps that we've done so far to ensure that everybody is up to the steps. So the first thing that we did was we added a writer and we selected Esri Geodatabase. And then I simply copied this location from the Fme Server authoring course. And this is because the department database folder does not exist yet. So you can either type this in manually, or if you were to go through the browse button, you could simply type it in here instead. And then once you've added that writer, we needed to change the feature types to use this writer instead of the null writer. So to do that, we selected the cogwheel, firstly for the voting places writer. And then under general, it would have looked like this. And so under parameters, general, we want to change that null writer to the department data file geodatabase writer. And this then exposes some additional parameters. And the geometry parameter in red, which means it must be set before we can save this feature type. So for the voting places, we'll set this to geodatabase point. And then you can go ahead and do the same thing for the neighborhoods feature type, but this time you'll be setting the geometry to geodatabase polygon. If at any point you're not sure about what this geometry setting would be, you can simply select the inspector icon above the writer to view it in visual preview, and then you should be able to clarify which geometry you need to set this writer to. So for the voting places, the geometry was point, and for the neighborhoods, the geometry was polygon. So before we run this workspace, there's one last step that we need to take, and that is that we want to set one of the parameters for the geodatabase writer. So we can go under the navigator, and for department data, if you select the arrow on the left-hand side of this writer, there should be a drop-down menu that appears. And then we want to modify one of these parameters. So we can go down to the parameters and again expose the drop-down. And the default for overwriting a geodatabase is no. However, since we'll be running this workspace to do some testing, we want to make sure that the same data isn't written out multiple times. So we can change this parameter to yes. So to do that, simply double click on the overwrite existing geodatabases parameter. And then this should show an option for editing all of these parameters. And so we can check the box for overwriting the existing geodatabase. And this should change the value from no to yes. So that's under the department data, under parameters, and then for overwrite existing geodatabase, just double click on that parameter and check the overwrite existing geodatabase box to change it to yes. The last thing that we can do, since we're already in the navigator, is we can simply remove this null writer. It doesn't really matter if it's there or not, but since we're no longer using it, it's a good idea to just clean it up and remove it from this canvas. So to do this, we can right-click on the null writer, and then we can simply select Delete Writer. So we can now test run this workspace in Fme Workbench to ensure that it is writing out correctly before we publish the workspace up to Fme Server. So to do this, we can just select the Run button at the top of the canvas. And this will pop up a translation parameter values box, and you can ensure that the source data and the file geodatabase location is set as you specified. And then you can just select Run. If you have an unexpected input dialog pop up, there's no need to be concerned about that. This is from the KML reader because Fme has detected there are some features that read that do not match the neighborhood feature type that we have specified, but that's okay because we're not interested in any of these feature types, so you can just select OK here. So it looks like the translation failed. So let's have a look and see if we can work out what happened there. Okay, so what it looks like happened is since I opened the data handling exercise to begin workspace, it's reading in the elections voting.gml. However, yesterday we changed the name of that source dataset to new elections voting for the previous exercise. So if anybody encountered that issue, you'll be able to see that at the bottom of the log file, it will say translation failed. So to fix this, we can go into the navigator under election voting. And for the source dataset, we can go ahead and change this. So again, if your translation did fail, you'll be able to see this in the log file. And the reason that it failed is for an XML module error. And this is because we changed the name of the source dataset in yesterday's exercise. So this workspace that was a begin workspace is designed with the election voting GML, and we changed this to new election voting in exercise 2.1. So we can go ahead and fix this by under the elections voting GML reader in the navigator, select the drop-down arrow next to election voting, and then in the source geography markup language dataset, double-click on this parameter, so the parameter directly under election voting. And we can go ahead and reference this to the file that we renamed yesterday, so the new election voting. So in order to do that, we can select the three dots here next to the source dataset, and this will open up the folder, and we'll simply select the new elections voting folder, that GML file that is now in this location. So if you used your workspace that you saved yesterday, you wouldn't have run into this issue because we had already set that up to use the new election voting file. However, if you use the workspace from the server authoring folder, this was set up to use the workspace before it was renamed. So we should then be able to go ahead and run that workspace. And this time you should see that there are numbers coming out of the Clipper port going into voting places. So we can see that this source dataset has now been able to be written out. Again, if you get this unexpected input dialog box, it's nothing to be concerned about, and you can simply check the box to do not show again. It's referring to feature types that have been read, but that we are not using in our workspace. So at this point, you can go ahead and have a look in the translation log, and we can confirm that the workspace ran successfully by looking under the features written, and we can see that as well as the neighborhoods, polygons file being written, we've also got voting places split by their feature type in this geodatabase. So I'll just give everyone a moment to get to that point, and then we can look at publishing this workspace to run on Fme Server. So if you did fall behind during that section, then there's no need to worry. You can simply follow along with myself for now. And once we've finished making the edits on the workspace, you can go ahead and open up the completed workspace to have a look at what we've done. So the next step in this exercise is to publish the workspace up to Fme Server. So in order to do that, we can select File, Publish to Fme Server, and then you can choose the Fme Server connection. I didn't change the name of mine, however, I believe Laura set it on the first day to training. So whatever your connection is named, it should be the one listed under there. If you're not sure, you should be able to see that there is a URL, http://localhost, and that is the Fme Server connection that you want to be using. From then you can select Next and give your workspace a name that you will understand. So I'm going to simply change this to exercise 2.2 to keep the naming convention that I've been using as with my other workspaces. And this time we don't want to upload any data files because we're going to be using the ones that we uploaded already to Fme Server. So you can leave this box unchecked and then select Next. And we can leave it at the job submitter, registered service. We're not interested in attaching this workspace to any other service for this exercise. So then we can select Publish. And once the workspace is published successfully, this will be displayed in the translation log as well. So now we want to return to the Fme Server web interface, and we can go ahead and run this workspace, specifying the resources location that we set up at the beginning of this exercise. So you can return to the Fme Server web browser, And we can go to the Run Workspace page, select the training repository, and select exercise 2.2. And at this time, you should notice that the published parameter values are blank. And this is because we did not publish any data up with the workspace. So Fme doesn't have a shortcut or a reference point to these files. So now what we can do is we can go and click to browse, and we can find these resources that we uploaded in the Data Elections input folder. So for the KML file, we can click to browse. And this should open a pop-up window onto the Fme Server resources page. So from there, we can navigate to our input folder by going into Data, and then selecting Election, and then selecting the input folder, and lastly, we can select the KML file, so the Vancouver Neighborhoods KML. Once you have selected this, you can either select the file itself, or you can select the plus button on the right-hand side, and this file should now be listed under the selected items. So once you select OK, this file will now be uploaded into the source KML dataset to be used in this workspace. And notice, as we mentioned, rather than referencing the full file path, this is referencing the Fme shared resource data folder. We've just had one user say that they cannot see the option for published parameters. If you selected the completed workspace on this page rather than the start workspace, then that is expected, because in the final steps of these exercises, we're going to make these parameters not available to be edited by users. So if you are using the completed workspace, then just follow along with me for now, and we can go ahead and see what we're doing in those next steps, and you can rejoin towards the end of this exercise. So once we published the workspace to Fme Server, we went onto the Run Workspace page, and then we selected the training repository, and we selected the last published workspace, so that was exercise 2.2. From there, these published parameters are now blank because we didn't upload the files with the workspace. So we need to specify these source datasets from the resources folder that we created in Fme Server at the beginning of this exercise. So in order to do that, we can select Click to Browse, and this will open the Resources folder, and we can then navigate to the input folder that we created earlier in this exercise. So we can select Data, and then we can select the Elections folder, and then the Input folder, and we can select the Vancouver Neighborhoods KML file, Once selected, this will be listed under the selected items on the right-hand side of this window. And you can then select OK, and this will now be listed as the source dataset for the KML file. Once you've done this, you can then repeat the process for the GML file. So we can select Click to Browse. And then we'll select the Data folder. The Elections folder. And then we'll select the Input folder. And this time we'll select the Elections Voting GML file. So you can do that by selecting the plus icon on the right-hand side of this file name. And this will now appear under the Selected Items box. And once you've done that, select OK. And now both of the source datasets listed under the Published Parameters panel should be populated. So the last thing that we need to do before we run this workspace is there's one more published parameter that needs filling in, and that is the destination dataset, so the file Geodatabase. So in order to do this, we can select the three dots on the right-hand side here. And this will take us to the same resources window that we saw for the source datasets. So we created a separate output folder for this destination dataset to be written into. So that was in the Data folder under Resources. And then it was in the Election folder. And this time we're going to select the Output folder. And at this point, you'll notice that there are no items available, and that is because this geodatabase doesn't exist yet. So we need to specify this folder in our file path output. So once you've got into the output folder location, you can select the text box where Fme shared resource data election output is written, and then you can simply add department data.gdb. So for this destination geodatabase, you should navigate to Resources, Data, Election, Output, and then once you're in that location, you can select this text box at the bottom of the window, and after the output /, you simply need to type departmentdata.gdb. And once you've done that, you can select OK. And the Run Workspace page under the Published Parameters should now look like this. So your Google KML source file should reference the Fme shared resource data, and then the election, inputs, Vancouver neighborhoods.kml, and for the GML source dataset, this should reference the same path, so the Fme shared resource data, elections, input, and this time it will reference the new election voting.gml. And lastly, for the file geodatabase destination, this should reference the Fme shared resource data folder, election, output, and this time it will reference departmentdata.gdb, and this is something that you will have need to written in. If you're not sure about this last value, you can simply copy it from this step in the exercise. This specifies the correct file path that we need to be referencing. So once you've reached that stage, you're now ready to run the workspace, this time using these permanent files that we've uploaded onto Fme Server. So once this workspace has been completed, we can now confirm that the process was successful by navigating to that output folder in Resources and confirming that the department data geodatabase was created. In order to do this, we can select Resources under the menu in Fme Server on the left-hand side. And then we can select Data, Election, and you'll already see that the date has been altered from today to when we last run the workspace, so that looks like a good sign. So lastly, we can select Output. And as you should be able to see, the department data geodatabase file has now been created in that location. So the final step of this exercise is to apply this Fme Server parameter, so that Fme shared resource data parameter within the workspace, so that we don't even need to reference it as a reader at runtime, as a user at runtime, sorry. And once we've finished off this exercise, we'll take a break before moving forward, so that if anybody has any questions about this exercise, we can catch up with you then as well. So for this final step, we want to apply this Fme shared data resource parameter to the source and destination dataset locations. And this means that we no longer want these parameters to be published, because we don't want the user to have any influence over these datasets and be able to change what the files are being referenced to. So the first thing that we need to do is return to the workspace that we were just using. And then under the navigator, we want to have a look at the user parameters. And under there, have a look at the published parameters. So this is under Navigator, under User Parameters, and then under Published Parameters. So you may recognize that these are the three parameters that have been viewable on the Fme Server window when we go to run the workspace. So since we no longer want those options to be available to the user running the workspace, we can simply delete these three parameters. So in order to do that, we can right-click and select Delete. So again, that's under User Parameters, and under Published Parameters, we can right-click and delete all 3 of the published parameters that are listed here, because we do not want the end user to have any influence over the files that this workspace is using. So we can right-click and select delete. So now the final step of this exercise, since we've taken away the option for the end user to specify these source and destination datasets, is that we need to set them in the workspace to reference that Fme server location to ensure that it is using the data available on Fme server. So we need to do this for both of the source input datasets and also the destination dataset. So in order to do this, we can go in the navigator under Vancouver neighborhoods, and we want to be changing the source Google KML file value. So to do this, we can double click and then I'm going to select the Open Text Editor, and this means that I can use the Fme parameters here to write this out rather than having to type out the entire thing manually. So this is under the Vancouver neighborhoods. In the source file, I simply double-clicked on this to edit it, and then I'm editing the source file using the text editor. So at this point, we want to change this value from referencing the local file to the Fme shared resources data variable that we saw when we previously ran the workspace on Fme server. So I'm going to delete the section from C to boundaries, just leaving the end file name there. And then I'm going to replace that with the Fme shared resource data election input file path. So to add the Fme shared resource data, I can have a look on the left-hand side under Fme Parameters. And then select Fme shared resource data. And you'll notice that this comes up with the $ and parentheses. And this is just the symbols that we use to tell Fme that this is an environment variable. And this refers to the data folder in resources. However, since we created 2 additional folders, we also need to specify those. So we can go ahead and add a / here, election, and a / input. If you'd prefer, you can simply go ahead and copy this file path from the exercise under step 10. These paths have all been listed, and this will ensure that you get the path correct. But it is the Fme shared resource data macros in the election folder, in the input folder, and then in the Vancouver neighborhoods.kml file. Once you've done this, you can select OK, and then select OK again. We then need to repeat this process for the GML reader and for the department data file Geodatabase Writer. So we can go ahead under the navigator, under the new election voting GML, and we can edit the source dataset here. So we can double click, and this time, just to make sure that we're finishing on time for a break, I'm simply going to copy and paste this over from the authoring course manual. So we can delete what's already in there. Looks like I didn't copy it over. And then we can paste this location into the source GML file. So for the GML file, we want to have Fme shared resource data, election input, and then actually, as we mentioned from exercise 2.1, we renamed this file. So make sure that you add in a new before the elections voting if you did copy and paste this value over. So this should now reference Fme shared resource data, election, input, and then new election voting.gml. And then we can select OK here. And there's just one more work step before we publish this back up to Fme Server. And that is to do the same thing for the destination dataset. So we can select the department data. And then for the file Geodatabase, we can double click and edit this as well. So once again, I'm going to copy the location from the Fme Server training course. If I can highlight the whole thing. And then we can edit the department data and we can remove what's already set in there and we can paste this new location. So that is Fme shared resource data, election, output, department data.gdb. So once you've done this, you should be able to see under the Vancouver Neighbourhoods KML, this is referencing Fme shared resource data. And you should also be able to see this under the election voting GML, and lastly under the destination dataset. And the final thing to check here is that there are no parameters listed under the user parameters, published parameters section of the navigator to ensure that the end user running this workspace doesn't have the option to manipulate these files. So the last thing that we want to do is publish this workspace back up to Fme Server. Since it's already been published once and we're not changing any of the services it's been running under, we should be able to select File and we should be able to select the Republish to Fme Server. So this means that we do not have to go through the entire publishing wizard again to simply specify the same settings as we did previously. So select Republish to Server under the File menu. And you should now be able to see a second published summary in the translation log. So the final step of this exercise before we take a break is we want to run this exercise again in Fme Server. So we can return to the Fme Server in your web browser. And we can then select the Run Workspace page. Select the training repository and select Workspace Exercise 2.2. And at this point, you'll notice that unlike when we have been previously running these exercises, there are no published parameters available. And this is because we deleted those so that we are using the referencing the files that are in the resources, and we don't want the end user to be able to change these or upload different files. So we've simply removed those parameters. So the last thing to do is to run this workspace. So even though we didn't specify those source datasets at runtime, since we specified them in the workspace, it's still using those resource folders resource files we uploaded at the beginning of this exercise. So in order to check that, we can then go ahead and have a look in the destination dataset location again. So that was in Resources, Data, Election, Output, and you should be able to see that this database was updated to a time just a minute ago. So we just have one more section to cover before we finish Chapter 2, which was on Fme Server and Data Management, and then we'll be moving on Chapter 3, Self-Serve Foundations, for the rest of this session. So the last thing that we wanted to cover in this course, which originally belonged in the Fme Server Administrator course. However, we thought it was important that as authors, you were aware of this as well. So moving on from sharing source datasets and using database and web connections, as an Fme Server author, there is sometimes the need to share other custom resources with Fme Server, depending on what your workspace is made up of. So these are just some things that you may have to get your administrator to perform these tasks for you. However, as an Fme author, if you are working with custom formats or transformers, or if you are working with Python or with R, then there is the need to share some of these, share some of these resources with the Fme engine in order for Fme Server to be able to run these workspaces correctly. And if you do not, then this might be the first place to start troubleshooting if you are using any of these elements in your workspaces. So firstly, when sharing custom formats and transformers, it is a requirement that these custom formats, so the FMX files, if you are familiar with these, need to be uploaded to Fme Server, just as you need to upload source and destination datasets in order for the Fme engine to have access to those custom formats. So there are 3 different methods to share custom formats with the Fme engine, and all of these involve placing this FMX file in the Resources Engines folder under the appropriate subfolder, so under Formats or Transformers. And you can either upload these directly through the web UI. You could publish this FMX file individually using the Publish to Fme Server option as you would a normal workspace. Or if you are using this custom transformer or format within a workspace, you will need to add the FMX file as a file to upload, along with any source datasets that you might be uploading. Secondly, if you are using Python with Fme Server, then as an author, you should be aware that the Fme Server engines choose a Python interpreter that matches the Python compatibility setting you have set in the navigator in the Fme Workbench parameters. If you are using any Python modules that were not shipped as part of the standard library, and if you had to import these into Fme Workbench, you will also have to do the same thing in Fme Server, placing them under Resources, under the engines, and again under the appropriate folder in plugins. So if you are using Python in your workspace, then there are some variables to consider when you are publishing and pushing this workspace up to Fme Server to ensure that it is running correctly. And lastly, if you are using R with Fme Server, then just like with Fme Workbench, there are some additional steps needed to execute these scripts to ensure that they run on server as they did on Fme Desktop. And that is just to make sure that the Fme engine has access to these packages in order to be able to run these scripts. So this section really is on the border between an author and an administrator role. However, it's good to be aware of if you are using any of these formats. And in particular, under the further reading for the module review, if this is something that you think you need to explore in more detail, then these resources should cover this for you. So in Chapter 2, over yesterday and today, we have had a look at how Fme Server handles data and how you can upload data to give Fme workspaces access to this data, both temporarily and longer term under the resources data options. And lastly, we had a look at how we can specify this resource location in a workspace so that it is authored to be used specifically with data stored on Fme Server. So now we're going to move on to Chapter 3, which is self-serve with Fme Server. So self-serve is one of the 3 core capabilities of Fme Server that we mentioned briefly in Chapter 1. And self-serve is key for allowing end users to make requests for data and to upload data, taking away the manual effort required by staff to enable them to concentrate on things other than providing data to the end user. So this chapter will take a look at how self-serve is implemented on Fme Server to allow the end user to request data to download, as well as perform file upload, and also to modify parameters so that they do have some say in the data and the layers that are downloaded by using published parameters. So self-serve is defined as a system that allows the end user to carry out their own data translations and transformations. And by doing this, routine data management tasks are offloaded from your staff to the end user. And by doing this, we can set up processes to allow the user to do this whenever they want, wherever they want, without relying on somebody else to do that back-end processing. What's important about self-serve with Fme Server is that the end user doesn't need to have any prior Fme experience or training in order to be able to use this functionality. And this is because using Fme Server, we can set up this functionality to be accessed by a customized web interface, meaning that if you wanted to, the end user wouldn't even need to know that Fme was running in the background to deliver this data to them. So when we refer to self-serve in Fme Server, we're referring to 2 different types of self-serve systems. The first one is data upload. So we've come across this before in Chapter 2 when we had a look at performing a series of different data upload tasks, and we can see that the end user is able to provide data onto the system. And a typical application of this would be that the user can upload data and have it validated. So this would mean that once they upload the data, it would run a workspace in Fme Server that would perform a number of checks on that data, and then the result would be sent back to the end user within the web interface that they are working from. The second type of self-serve is data download, and this is a system where the user is able to serve themselves with data. So as an example of this would be a data download system where the user can fetch their own data rather than having to be provided with it by making a request to a person and have it delivered manually. So within Fme Server, there are 2 types of data download. Data can be downloaded as a series of files in a compressed folder, or it could be streamed directly back into an application. So in a data upload system, this is where the user provides data for Fme Server to process. And this can be done in a number of different ways. It could either be done directly in the Fme Server web interface, or we also have the Fme Server app that was demonstrated earlier this week. And we also have the option to create a custom web page or application, which is running Fme Server using those URLs generated from Fme Server to run the workspace. Secondly, with data download, this is where a user can select different options to download data of their own choice. And this again can be done in a number of different ways. Either the user can be provided directly with access to the Fme Server interface, or they might have a link to an Fme Server app, which is essentially just a simplified version of the Run Workspace page. And they are giving access to this using token management, so they have no other access to run or use anything else on the Fme Server interface. They can simply use this URL to run one particular workspace. Or lastly, you could design a custom web page or application for the user to request download data. And in doing this, you can not set it up so that the end user doesn't know that Fme is being used in the background. So self-serve and services. So a service is a particular method of communication between a client and a server. And Fme Server provides a wide range of these services to carry out different operations. So each of these services is a tool that allows users to access the different Fme Server functionality through this simple interface. And this will determine what specific request is sent to Fme Server, and different results will be returned to the end user or the client depending on which Fme service is selected. So as an example, when we have been publishing the workspace to Fme Server, we have been publishing it to the job submitter service. And this means that this is performing the simplest action, much like when you run a workspace in Fme Workbench. It will simply submit a job and will not return anything other than the status of that job back into the web browser upon completion. However, there are other options for services, and so under self-serve, one example would be the data download service, which once you run the workspace, a URL is returned into the web browser, which returns the data compressed into a zip file. So there are a number of available services on Fme Server. Some of them you will see, and some of them are more behind the scenes services that are performing this communication between the client and Fme Server. So the first series of services is the transformation services. And these you may recognize as the services that are available when you publish a workspace to run on Fme Server. And then second, we have utility services, which we often describe as helper services. And this interacts with Fme Server to assist in more menial tasks in a way that is hidden from the end user. And lastly, we have the notification service. And this is used to pass messages into and out of Fme Server to what we refer to as topics, which we can then use to perform further translations in Fme Server. And we'll be covering this in more detail in Chapter 4 when we have a look at automations, which reviews the notification service in more detail. So when we publish workspaces to Fme Server, there are a number of different windows that we have to go through to make decisions about where the workspace will sit on Fme Server and also how it's going to be run. So the final window that we see in the publishing wizard is a panel for registering the workspace to a number of different services. And once you register a workspace to that service, it then becomes available to run using that service on Fme Server. However, what's important to note as we will work through is that not every workspace will be able to run on every service. It depends on what that workspace has been authored and designed to do as to whether it would be able to be run and whether you would want it to be run on a certain service. So under each service, there are a series of parameters that need to be set that will determine how the workspace will be run using these services. And what's important to note is that you can register workspaces to any number of services you choose. And then when you're on the Fme Server window, you'll have the option to select which service you want to run it under for that particular run. So for the first service that's listed on that panel, that is the data download service. And this is one of the services that belongs under the self-serve capabilities of Fme Server. And creating a workspace to run under this service is easy to do. Once you register a workspace to the data download service on publishing, this data download service becomes a way to run the workspace. So rather than selecting the job submitter, when you select the drop-down for services, the data download option is also now available. And what this means is rather than the results being written to a specific output location that you may have specified, instead they are delivered via a data download URL in the web browser, which you can then select the hyperlink, and this will download a zipped dataset containing all the data that was written out in that workspace directly to you in the browser rather than being written to any specific location. Creating data upload services is slightly different because there's no way to register a workspace specifically to this service. Instead, by publishing published parameters to source datasets, this will allow data upload to take place. So this is a utility service that we have been using in all of the exercises that we've covered so far whenever we've specified a source dataset by uploading to Fme Server. So depending on the requirements, there's two different ways to upload data, either specifically using the data upload system. So that would be on Workspace runtime when we perform a temporary upload, or also by performing a upload to the resources file system. So the resource file system allows this data to be uploaded and then used by any workspace that is available on Fme Server. And since this upload is persistent, data upload is no longer needed for every individual run. If you were choosing to create a customized solution where you had an end web application that was running these services, you could make the decision as to whether you were going to use the data upload service or have resources stored in the Fme Server resources file system. So let's get started on the first exercise for this chapter. And in this exercise, we're going to be having a look at registering a workspace to run under the Fme Server data download system. And the reason for this is that as a team, imagine you're a GIS team and you have a lot of requests for orthophoto imagery of the city you are working for. So what you want to do is provide a service where anybody in your organization can go ahead and request that data download without you having to manually do it. So the first thing that we need to do is create an Fme Workbench, and then we can register it to the Fme data download service so that anybody is able to access this data through running this workspace. So let's start by creating a basic Fme workspace. So we can return to Fme Workbench, and we want to create a new workbench, so we can select New. And then we want to create a blank workspace, so we can select Blank. So again, once you enter Fme Workbench, you can create a new workbench by selecting the New icon, which is the first icon in the menu ribbon at the top of Fme Workbench. And once you select New, you can select a blank workspace and then select the Choose button at the bottom. We won't be using the exercise 2 again, so you can either save that or not, depending on your preference. And then you'll be presented with a blank canvas where we can start creating this exercise, this workspace for this exercise to create a data download service. So once everybody has a blank workspace, we want to start by adding a reader to the canvas that contains this orthophoto imagery. So the first thing that we need to do is select Readers and then Add Reader from the menu at the top of Fme Workbench. Once you have the Add Reader pop-up wizard, the format that we are going to be using is GeoTIFF. So we can find that format by typing GeoTIFF into the canvas, and only one of these becomes available. So the format you should be selecting is the GeoTIFF format. And for now, we're going to select a single image, be ready to design this workspace. So next to the dataset, we can select the ellipses to open a file browser. And then we want to return to the Fme Data 2019 folder. So that's under the quick access bar of the menu in the file directory. So that's Fme Data 2019. And from there, we'll select Data. And this time we're going to be using imagery from the Ortho Photos folder. So we'll select Fme Data 2019, Data, orthophotos. And then for this example, we're going to select the one called 06-07-LM. That's about halfway down this list. And the reason we're selecting this file is because this is orthophotos above Vancouver, and some of them are over the sea. So we want to make sure that we're getting an image that's over land for testing purposes. So we can select this 06-07-LM1 so that when we're testing the workspace, we have something visual. So for that reader, that's a GeoTIFF format, and the data set is in orthophotos 06-07-LM. So there are some additional parameters that we want to make sure are set here. So the first thing that we want to do is set where the feature type name is coming from. So under the Parameters button, so that's the Parameters button here. This will then open up an additional pop-up window where we can specify where we want the feature type name for these files to come from. So it's currently coming from the format name. However, we want the feature type to come from the file name. And this means that when we start to read in different features, they'll be referenced by their file name rather than being referenced from the format. So rather than them all being grouped as one feature type, we'll have individual feature types for each of the files that we are reading in as we move on through the exercises throughout Chapter 3. So that was under the Add Reader parameters, and then under Dataset Parameters, we specify the feature type name to be from file names. And the last thing that we want to do before we add this reader to the canvas is we want to change the workflow options from individual feature types to single merged feature type. And this is because even though we were only using one image at the moment, as you saw in that orthophotos folder, there is a large number of source tiles of data, and so we want to be able to read all of them in without having to specify the individual feature type. So this is a way to make the workspace dynamic, or make the reader dynamic. So we've done 4 things here. We've specified the format as GeoTIFF. We specified the dataset as under orthophotos 06-07-LM. We then selected parameters and specified the feature type name as from file names. And we set the workflow options to single merged feature type. So now we can select OK. And you should now see that a reader has been added to your canvas. And at this point, you can notice that unlike in the previous exercise where it specified voting places or Vancouver neighbourhoods or the feature type name, now it simply specifies all. And this is because of the feature type merge that we set. So this is an indication that this reader will be dynamic. So the second thing that we want to do is add a writer. And even though these photos are stored as GeoTIFF, we want to write them out to JPEG because we know that this is a format that everybody should be able to view just using a Windows photo viewer, for example. So in order to add a writer, we can select Writers from the menu at the top and then select Add Writer. So for the writer format, this time we want to specify JPEG. And there are 2 different JPEG options. So make sure you're selecting the Joint Photographic Experts Group option. And for the writer dataset, for JPEG, you simply need to specify a folder rather than the file name. So we're going to write this to the output training folder. So under the quick access menu bar, we can go to FME Data 2019. And then we'll have a look in the output folder. And then we'll select the training folder. So make sure here that the folder is training, and then you can select the select folder button. So we have the format as JPEG. The dataset is the training folder. And the last thing that we want to do before we add this writer is change the raster file definition to copy from reader. So now we can add the writer to the canvas, and you should now have a reader and a writer on your canvas. So I'll just give everyone a few moments to get to this stage before we move on to add the transformers to this workspace. Okay, so we're going to add two transformers to this workspace. The first one we're going to add is a Raster Resampler. So in order to add a transformer to the workspace, you can simply start typing onto the canvas. So we're going to start typing Raster Resampler. And then you can find that from the list or continue typing and it will eventually become the only transformer available. And you can then double click on this transformer to have it added to the canvas. So the Raster Resampler transformer is going to be used directly after the reader. So we can now move that up and create a connection between the reader and the Raster Resampler. The second transformer that we'll be using in this workspace is the Raster Mosaicer. So again, in order to find this transformer, you can simply start typing directly onto the canvas. And the Raster Mosaicer should become available. So we can double click to add that to the canvas. And we can then make a connection from the Raster Resampler resampled output port to the Raster Mosaicer. And we can then create a final connection from the output port of the Raster Mosaicer to the writer, because these are the only transformers that we will be using in this translation. So currently on your canvas, you should have a reader, a Raster Resampler, a Raster Mosaicer, and then you'll have a JPEG writer. So at the moment, the workspace is not quite ready to run. As you should notice, the Raster Resampler has a red cogwheel, and this means there are some parameters here that still require values added to them in order for this transformer to perform its job. So in order to edit these parameters, we can click on that red cogwheel, and this will open up the Raster Resampler parameters window. And we need to specify the raster size. So in this example, rather than using rows and columns for the size specification, we want to change this to cell size. So for that first parameter, you can select on the drop-down and then select cell size. And then we're simply going to set these as static values. And we want these images to be square, so we can set the cell size as 5 and 5. Once you've done that, you'll notice that those boxes are no longer red, and this means that the transformer can be saved and will now perform as expected if we were to run the workspace. So at this point we can select OK, and now the cogwheel will no longer be blue. Will be blue, sorry, will no longer be red. So we'll just do that step one more time. So in the Raster Resampler, you can set the size specification parameter to cell size. And then for the X and Y cell spacing, you can give both of these a value of 5. This workspace is now ready to run. So first we can save this workspace, and then we'll test it out in Fme Workbench before publishing it to Fme Server. So in order to save the workspace, we can select this save icon. And we want to save this workspace in the Fme Workspaces folder. So under the Quick Access tab, select Workspaces. And this should take you to a location in Documents, Fme Workspaces. And this is the location that Fme Workbench saves workspaces to by default. So we're going to save this exercise as exercise 3.1. So that was under the Quick Access tab, the Workspaces folder, and then we can give the file a name of 3.1. And select Save. So now that we've saved this workspace, we can run it and make sure that the JPEG is being written out correctly in Fme Desktop before we publish the workspace to run under the data download service in Fme Server. So we can select the Run icon in the menu of Fme Workbench. You can select Run here as we've already set up these parameter values. And once the workspace has run successfully, if you select the writer, and then you can select the Open Containing Folder icon, which if you select the writer, there should appear a floating ribbon above the writer, and this is the fourth icon along. It's a yellow folder, and if you hover over it, it will say Open Containing Folder. And this will take you to the folder where this dataset is stored. So once everybody's been able to run that workspace, we can then go ahead and have a look in this location to check that the JPEG has been written out as expected. So we can select this folder, and as you can see, it's taken me directly to the Fme Data 2019 output training location that we specified in the JPEG writer. And you can see that both the JPEG is in there along with its associated file. And you can see that the file name has been taken from the reader file name as we specified copy from reader in the writer parameters. So now we can open up this image, and as you can see, it's provided an image of a built up area. So the last step of this exercise is to publish the workspace up to Fme Server, registering it with the data download service. And in this way, this means that once the workspace has been run, this JPEG image will be returned to the end user as a file in a compressed zip file. So they'll then have access to this image without needing to make a request to anybody else within the organization. So once you've inspected that file, we can go ahead and publish to Fme Server. So we'll select File, and then we'll select Publish to Fme Server. We'll be using your training connection here. And then we'll select Next. And since this workspace is using data that we have not published to Fme Server, we'll need to make sure that this Upload Data Files box is checked so that the workspace has access to that GeoTIFF image in order to run successfully. So on the Publish Workspace page, make sure it's being saved in the training repository and that you have checked the box to upload the data files. If you want to check those files, you can select the File button and you'll be able to see that it is uploading the GeoTIFF image that we have been using in this workspace. So once we've done that, we'll be taken to the Registered Services windows of the Publishing Wizard. And previously, we've simply been moving past this page because we've only been wanting to run the job. However, this time we're looking at different formats of self-serve. And in this exercise, we're looking at data download. So in order to register this workspace to run using the data download service, we need to select the checkbox here next to data download service. And you can also leave the job submitter one checked. And this just means that when a user is running the workspace, they have an option of which service they want to run the workspace under. However, if they did choose the job submitter service, no data would be returned to them. So under the properties for the data download service, we can select the edit button. And by default, this will select all writers in the workspace to include in the zipped file for download. However, it's good to just check. So when we select the edit button, next to the include writers to download parameter, we should be able to see training JPEG. If you were to have multiple writers on your workspace, this is then where you have the option to only include certain ones in the data download service for the end user. But for us, we just want to download that JPEG file. So we can select OK. And under Register Services, once you've got the data download service checked, you can publish the workspace to Fme Server. So the last part of this exercise and the last thing that we'll have time to do today is to go on to Fme Server, and we can run this workspace under the data download service and see how this differs from how we have been running the services previously, and see our first example of self-serve in Fme Server. So in order to do that, we can return to the Fme Server interface. And then we can go ahead and run this workspace. So we can select Run Workspace from the left-hand side menu, and then select the training repository. And this time we want to select exercise 3.1. And by default, this service is selected as the job submitter. However, we want to run the workspace under the data download service. So notice with the job submitter service, there is the option to specify the destination JPEG folder. And once we change this to a data download service, this option is removed because we are no longer writing the data out to a specific location that we set. Instead, we're writing the data to this zipped file that we are going to download and have access to straight away. So once you've selected the repository, the workspace, and changed the service to run under data download, we can simply leave the published parameters as they are because we uploaded this file with the workspace, so it should now run successfully. So once you've set this up, you can select Run, and we'll stay on this page until the job completes running. And now you'll notice, as well as this completed window that contains the job ID and the number of features written, we also have an additional parameter listed that is the data download URL. So once you select this URL, you should see that a zipped file instantly starts to download in your web browser. So once your workspace has completed running, you can select this data download URL, and this will download a zipped folder containing that JPEG result in the folder. So the last thing to do to complete this exercise is just to make sure that that JPEG was successfully written out. So we can then select this zip folder to open it, and we can see that the JPEG folder has been written out along with its associated folder. So now if we were to double click on this file, we would see exactly the same as the output that was presented to us when we ran the workspace in Fme Workbench. So as you can see, by completing this exercise, we've been able to publish and run a workspace using the data download service, and this demonstrates a method of self-serve in which the user can go ahead and request data via running a workspace and have it returned automatically to them within the web browser without any manual interaction with anybody else on the team.